Okay, so 41. The quantum efficiency of the photo detector is 0.1, and if one array photon on sent to detector, the one after others will detect photons. Okay, so this is the only information you have. So you only know the average is 10 because 0.1 times 100 is 10, and then you get nothing to keep solving this. You only get 0.1 times 100 is 10, and then you know that on average 10 times. But you need to find the RMS. Basically, that's the standard deviation. Okay, so solving to prove this is correct, you need to use the Poisson process, Poisson distribution, not Poisson process. Many things difficult. So the Poisson process tell you that Poisson process basically is a random variable which a Poisson distribution means that the random variable n can take what I'm reading about. The Poisson process distribution means that the random variable x can take any 0, 1, or positive integers, and the distribution look like this. This is and you can easily check that when sum over all the process, all the possible outcome is 1. This is due to the Taylor expansion of this exponential lambda. And so one can show that the standard deviation is basically square root of n, square root of lambda, and the lambda in here is just the 0.1 times 100. So the answer is the square root of 10, which is close to 3. So the answer is E. This problem is somewhat difficult. Okay, so how about we start 42? Okay, so 42 say that two students perform experiments. They drop a ball from a rest from known height above the ground and measure speed just before it strikes ground. From repeated measurements, students eliminate uncertainty in the measured speed of the ball must be 10%. So you will know one thing, which is the velocity is 10%. So basically, you know your velocity is the velocity naught plus 0.1 velocity, and ask about uncertainty in the kinetic energy. So kinetic energy is basically square of root of square of it. So basically, it's v naught squared plus or minus 0.2 v naught plus this term squared, but we can neglect this term. So the answer is like 20%. Okay, and 43 asking about which one represent the wave function of Schrodinger equation in 2s. Basically, A is C times cosine, and this is impossible because you know the answer should have some dependence on the radius direction. And the B said that so you need to remember that 2s orbital is S orbital is spherical symmetric, so there should be no theta and phi in the equation. So D and E are not okay. So the only remaining is A and B. It's B and C. And the C is the 1s orbital. The B is the 1s orbital. You need to remember this. So the answer is C. Basically, there's a fact that for the NS, the wave function looks like some polynomial with R, and times exponential to something. And the important thing is this PR of R contains a -1 roots in the direction of R. So for 2s, the P of R should contains 1 roots. So now C contains 1 roots, basically R equals to A naught. So the answer is C. Okay, so 44, basically you have some three orthogonal wave function, and you combine them into another wave function and ask you about A. This is easy because you just need to do you know that you want this wave function to be 1. So they tell you that A squares times phi 1 plus phi 2 plus phi 3 which is 1. And then this is 1, this is 1, this is 1. This tells you that 3a squared is 1. And then the cross term is vanished because the cross term is because we know that phi 1 and phi 2 are orthogonal. So the answer is 1 over square root of 3. The answer is A. The answer is A. And the 45 said that the matter wave. Okay, you can read the question. Basically, matter wave from region 1 and escape into region 3. Okay, so and ask about what's the form of the matter wave. Remember that h bar k squared 2m equals to e minus v. So if in region 1 this is k, in the middle is k prime, in the left is k. And then satisfy this. So this tells you that in region 3 it should be still related to k. And because there are no special symmetry, so the answer should be some kind of exponential ikx form. So the answer is A. The answer is A. Okay. Okay, so 46. Okay, so 46 is also easy. You have two springs, and one with force constant k1, one is force constant k2. As I ask you about the stretch length and the potential. Okay, so basically force is the same. So F equals to kx, tell you that the x is proportional inverse of k. Since k1 is larger than k2, so delta x1 is less than delta x2. So this is the first part. And the second part say that ask about the potential. Basically, the potential is half kx squared, and the force is equal to kx. So you can write it as force squared divided by 2k. And the force is the same, so it's the same results. Delta u1 less than delta u2. U1 less than delta u1 less than u2. So the answer is x1 less than x2 and u1 less than u2. So what we should choose A. Okay, 47. So basically there is a stone glued on top of light wood, and so left hand side there is a stone, the right hand side there is a stone, and but he flip and ask about the amount of water on the amount of block on the water. So basically, this is the amount of block on the water here, and this is the amount of block under which you need to solve it. But due to the basically we don't have to do any calculation here because due to the Boyle-C formula. Okay, so let me write down the Boyle-C. Basically, this is the mass. The Boyle-C formula is the water times the volume volume inside below the liquid times g. Okay, so the from left diagram, we have something which is fixed equals water times a half of the block times g. And the right hand side, we have the same W, same G, but something unknown plus at least a stone, or a stone. So these two must be the same. So this tells you that this one must be less than half times block, the volume block. So it's less than 50%, less than 50%. So the answer is A. Okay, so 48, unity start from rest and rose to the inclined plane without sleeping. After sometimes, what fraction of the disk total kinetic energy is the rotation kinetic energy? Okay, so you need to remember some formula. Let me remind you. Basically, you can find rotation energy, and you find a disk total energy, and you do their ratio. Then this is the answer. Okay, so you have a disk. Okay, so from here, your velocity is radius times alpha, and this is the first one equation, and so your translational kinetic or energy is this one. This is use larger, and the rotation energy is the half I omega squared. So total energy is both. And what's a unit disk? So unit disk tell you that I is equal to half mr squared. This is omega. So you can plug this into this. You get a rotation equals to half mr squared omega squared, which is 1/4 mv squared. So the total energy is 1/2 plus 0.25, which is 0.75 mv squared. And this ratio is what we want: rotation over total, and so rotation is here. So it's 1/3. Yeah, it's 1/3. The answer is B. Okay, so 49, two projectiles are launched from ground level with the same initial speed. So basically, you have two projectiles, and they have the same initial speed. And but one of it has one of it has 1, one of it has 2, and you know h1 is 2 times h2. And you have theta angle and theta angle 2, and ask about the relationship if you know the ratio of h, and you try to find the ratio of try to find some relationship with theta. Okay, so the only thing we need to get is the function from h to theta. Okay, so this is easy because we know that the speed contains two components. One is v not cosine theta, which is the x direction, and v not sine theta is the y direction. So v not theta, there's a v formula that v squared equals to v not theta squared minus 2gs, because v not theta is on the y direction, but there's a gravitational acceleration. So and the volume is and the velocity is 0, then s goes to its maximum. So this in our notation, this should be called h. So h is v naught squared sine theta squared divided by 2g. Okay, so we have h1 over h2 is proportional sine theta 1 squared over sine theta 2 squared. So sine theta 2 over sine theta 1 squared is 1 over square root of h1 divided by h2. So this is square root of 2. So sin theta over sin theta 1 over sin theta 2 is the square root of 2. So the answer should be B. Okay, so 50. Okay, we first read 50's problem. Basically, you have object and there's length 1, and after length 1 it becomes here, and you put another object length 2, and then ask about the length. So basically, you have this one put in here, and just ask about the true image produced by light length 2. So we don't care about length 1, all we care is length 2. So this can be solved by the formula of length. So basically, you have length, and this is, there's one object which is close is 10. Right, if there's a 10 meters from this one to length 2, and I tell you that the second length we focus 20. Okay, so we can use the formula 1 over p plus 1 over q is 1 over f, and then there's a formula say that amplify is basically the minus q divided by p. This 2 is important, we will use it. So 1 over 10 plus something equals to 1 over 20, so the x equals to minus 20. Okay, so let me explain. So in length, this minus 20 means that this minus 20 means that it's in so for the p, if p is positive, which is here. For the q, if q is positive, which is here, if q is negative, which is here. So now this q is negative, so it's here. And so when q is less than 0, this means that it's the virtual image. Okay, so you solve it. Basically, it's the virtual image, and you see there's a m. So your m is 20 minus 20 divided by 10. So which is 2. Right. So that means if the original object looks like this, then this one should look like this. So should look twice, but still downward. So basically, it's virtual and inverted related to the original object. Related to the original object. So the answer is C. Yeah, basically that's it. And I will see you guys in next video. Thanks.